So the last thing we were talking about, or second last thing, was this percent composition. So if we do ratios, if you look at this picture and we ask for adults to children, you can see there's 6 adults to 8 children. And uh, another way to do that is to divide each number of things that you're looking at, children and adults, by the smallest number, and you'll get this 1.33 to 1 ratio. And then if you multiply those by something to get them to be a whole number, you would use 3, because 3 times 1.33 is 3.99, which is essentially 4, and 3 times 1 is 3. And so you have a 4 to 3 ratio, which is the same thing you could get if you had 8 to 6, and you sort of reduce that, you would get 4 to 3 as well. All right. So this dividing by the lowest number is another way to determine the ratio. And that's important because we're going to do this empirical formula thing. So what we're going to do here is try to get from percentages to a formula. So in this case, sodium is in this compound, and as is sulfur, right? Here's sulfur. So there's sulfur in this compound, as is oxygen. Oxygen blue, and that's here, oxygen. Okay, so we're trying to find the compound formula for this compound given the percentages. And the steps to do this are you convert the percents to mass. And the way you do that is just taking literally the percents and making a mass. And we can do that because if we assume we had 100 grams of substance, then if we had 100 grams and 32.38% is sodium, then 32.38 grams would be sodium. And the way I tell you to think about that is if you take a test with 100 questions and you get 32 right, then you would get a 32%, right? So we're just going to turn every one of these percentages to grams because we're going to assume in each case that we had a 100-gram sample. And if we have a 100-gram sample, then all the percentages would turn to grams. And so that's how we start. Come on, blue. Here's blue. And we'll do that over here, I guess, hopefully. 44.99 grams. All right. And then the next step is we go from mass to moles. So we have all these masses and we got to turn them into moles. So starting with the sodium, we're going to turn 32.38 grams into moles. So to turn grams to moles, this unit has been all about this. You're going to go to the periodic table and you'll see that sodium is 23. Actually, let me do it this way. I think I have a new idea. Let's do it this way. All right. So if you go to the periodic table, and you will see that 1 mole of sodium weighs 22.9, if it's 98 or 99 ballpark. Let's go with 98 grams. All right. So then if you divide 32.38 divided by 22.98, that's what I said, yeah. It's 1.409. So that's 1.409 moles of sodium. And then we do the same thing with the sulfur. So our 22.65 grams of sulfur, 32.06, I believe, grams of sulfur in 1 mole. That's from the periodic table. So 22.65 divided by 32.06 is 0.706 moles of sulfur. And then we're going to do the same thing with oxygen. It's occurring to me yellow was an awful choice, but you know, what are you going to do? All right. Oxygen is the last one, so that's 16 grams in 1 mole. And that'll give us, so 44.99 divided by 16, 2.81 moles of oxygen. All right. So then the next step is divide by the smallest number. So of these moles, 14.09, 0.706, and 2.81, the sulfur is the smallest. So we're going to divide everything by that. How am I going to do this? Let's go with, I guess, I'm going to change to black. So this is the smallest. And that's a little shout out to the Steelers. All right, so we're going to divide everything by the smallest. So 0.706 into 1.409 divided by 0.706 is 1.995. All right, and then 0.706 divided by 0.706 equals 1, and 0.281 divided by 0.706 is equal to, for the oxygen, 2.81 divided by 0.706 is 3.98. All right, so now these numbers are the subscripts. So for sodium, the 1.995 is what goes down here. So we're going to call that 2. So it's Na2. And then the 1 here from the sulfur, we're going to call that 1. So the sulfur has a 1 on it. And then the oxygen, 3.98, we're going to call the 3.98. Essentially, we're going to round that up to 4. So the formula for this compound is Na2SO4. And so what we've made is sodium sulfate, or what we found based on that percentage. All right. Here's another one. So we have, in this case, 57.14% carbon. So we're going to call that 57.14 grams. And we're going to turn the nitrogen into grams as well. So 9.52 grams of nitrogen. So we're taking that percentage and just turning it to grams. And then we're going to take the oxygen, which is 27.18%, into 27.18 grams of oxygen. So that's the first step. The next step is to convert everything to moles. So oxygen is 16 grams in 1 mole. So 27.18 divided by 16 is 1.698. 0.699 even. Okay, so that's how many moles of oxygen we got. And then we'll do the same thing for nitrogen. So nitrogen on the periodic table is 14.0 grams in 1 mole. So that's going to be 9.52 divided by 14, 0.68 moles of nitrogen. And then the carbon, we're going to do that as well. And 57.14 grams is 12.0 grams of carbon in 1 mole. And that will get us 57.14 divided by 12 is 4.76 moles of carbon. So the next thing is to divide by the smallest, and we're going to identify, in this case, the smallest is the nitrogen, right? So here's the smallest number. So we're going to divide everything by 0.68. And that will always become 1 in that case. The carbon one will become 4.76 divided by 0.68 is 7. And the oxygen will be, if I get to purple, 1.699 divided by 0.68, 2.498, which is basically 2.5. So what this means is our formula is C. Hold on a second. I hate that this takes so long, but so it's C7 and then H this case, I guess. Yeah, where's the H? Is there no H in this? Oh, crap. I did all this without H. That's unfortunate. Okay, so it's C7, the N. I can still do this. Actually, I can do it pretty quick because hydrogen is pretty easy. So let's make hydrogen. Let's go with orange. All right, so hydrogen, I got to fit somewhere here. So using this one, 6.16. All right, 6.16% becomes 6.16 grams. So we're going to convert that to moles. So that's 1 gram and 1 mole of hydrogen, which gives me 6.16 moles. And then we're going to divide that by the lowest number, which is the 0.68. And that's going to give us, for hydrogen, let's go backwards. Does that stay orange? Yes, it does. So 6.16 divided by 0.68 is 9. So that's going to give us 9. So it's C7H9N1, and then O 2.5. So this works pretty well, except for the fact that our O is not a whole number, it's a fraction. So we need to multiply all those by something to get them into whole numbers. And if you want to memorize this, you can. So we are at a 0.5. So the idea is to multiply by 2, or you can just basically multiply by 2, then 3, and then 4, and see if that gives you a whole number. So in this case, we're going to want to multiply everything by 2 to get a whole number, and that'll give us C14H18N2O5, and that's the formula of our compound.